Rise of the machines. So, not exactly. It's about 10 years ago. I was listening to a podcast called The Java Posse. Who knows The Java Posse, by the way? Anyone here? One? Okay, well. It's a podcast, but yeah, they were talking about a continuous integration server. At that time, we didn't have one at work. And they were called Hudson. And I thought, okay, great, let's automatically build our software. So I installed this Hudson on a machine, on a server in our environment, pointed it to our CVS repository at that time, and forgot about it. But then, 3 days later, Hudson sent me an email, said, hey, your test failed. I said, wow, this is really magical. This is a magical moment. This is really the beginning of the rise of the machines. Now, actually, fast forward, 11 years forward, where are we? Where are we with continuous integration? That's what we should do, continuous deployment. We also should do that. So that's history. That's where we are right now. So rise of the machines is kind of there, but how did it expand? So I didn't want to do a talk about the continuous integration pipeline, your development pipeline. It's more something else that I want to talk about. So here's the disclaimer. This talk will not be about a build pipeline. I will not tell you how to build a better pipeline, how to automate stuff in your build pipeline. This is not what this talk is about. The talk is also not about how to write better chef and puppet scripts. That's also not what this talk is about, configuring your environment automatically. Nope. It's also not talking about how you write better scripts on your server that run somewhere. This is also not what this talk is about. So you might think, what is this talk about? Well, so I've been fishing around a little bit within Atlassian and within other companies and seeing, hey, what are you doing to automate your daily development tasks? So this talk should give you can't just take these examples that I show you today and put them directly into your work. Well, some of them you can, but most of them you can't. But it should give you an idea, open your mind a little bit, that you can automate much more at work that you probably have. But let's start with looking at where are we in our rise of the machines in our daily lives. So I'm actually keen of having this thing here in my apartment, running around and cleaning the floor. It's great. It's freaking expensive for just a vacuum cleaner. So I still try to convince my wife that we should have one of those, but it's still a fight. But things like that, like the Nest, that's everywhere. I just installed this Philips Hue lamp so I can talk to Alexa and turn on my lamps automatically. That's cool stuff. So we are there now. And then these things here, automatic driving cars. We're going to see them. We're not there yet. We're going to see them in the next years coming more and more. Maybe we have to wait 5, 10 years until it's really something. But we're starting. We're starting slowly. So Volvo has actually developed something where they have a human detector built in, and it detects human in front of the car, and the car stops automatically. And it looks like this here. Oh my God! Oh, shit! Wrong video. Damn it. Maybe we shouldn't trust the robots that much and not do this. So let's start actually with the talk, the rise of the machines in software development. I'm an old Java developer. My name is Sven. I work now for Atlassian as a, what did I write on the slide? Evangelist. I call myself different from day to day differently. So what I do is I try to find good stories and bring them to people and try to open their minds in teamwork and also in automating stuff. as I said, if you think about automation, you think about automatic deployments, builds and tests, and then maybe small scripts that are running around. But this is just the tip of the iceberg. Today, we will hear a little bit more about where else you can automate stuff. You can automate your engineering health. You can automate your support, your stand-ups, your merchant strategies, your code reviews, and even your operations. You might think, let's see. So as I said, I was looking around and tried to find bots and put them in buckets. So we will talk about coding bots during your coding phase, then testing bots that helps you better testing, some operation bots, some service bots, and then also some report bots. But the first bot I actually found, or whatever it's called, bot or script or whatever you want to call that, some automation software. The first automation software that I found has actually nothing to do with all these things. I couldn't fit it in the bucket, but I want to tell you the story anyway. So assume you're starting your new job. It's a new job, you're currently starting it, it's the first day at work, and then people show you around, you shake some hands, everyone explaining, this is our system that we build, this is the software that we use, and after 3 hours you think your head's gonna explode because there's so much information that you got, so you're happy actually coming to your workplace, coming to your desk, and there is it, your brand new computer, and said, welcome, I'm a brand new computer, please install software. And then you're going to start for the next 8 hours installing all these things that you need to fulfill your job. Actually, what you should do is you should ask around, what software do we use here? What IDE do we use here? What other software, what other add-ons or so should I install? Are we using Git or Mercurial or whatever here? So what should I install? So of course, we at Atlassian, we have the same problem. So what we do is we have this Confluence page. Yeah, there's everything on it, what you should do. Maybe you have a Word document or some other place where you put that. We put that in Confluence. So, and that says everything that you should do. So set up your Bitbucket account, for example, and upload your SSH key and stuff like that. And then, of course, also configure Maven. And if you configure Maven, you know you're going to start Maven, and then let Maven download the internet for you. And that, as we know, takes a long time. So in between, you can do a lot of other stuff. Install your Postgres SQL or a database or IntelliJ or whatever. And then if you're still waiting for Maven, that can also be can also be. So here's some good articles that you can read that dive you deeper into the job. So we have that page. And I was skimming through it and said, oh, yeah, interesting. But then I found actually the second comment on that page is, why are you not using Agent Charlie to automate these things? I said, Agent Charlie, what's that? So it's actually a small script that you just start. And then it's Agent Charlie here. This is Agent Charlie. And Charlie is actually doing the stuff for you. Charlie is downloading the software for you, installing the software on your machine, and configuring it. So actually, Charlie is not a piece of software. It's a bunch of scripts, Puppet, Shell scripts, Ruby scripts that we stick together. And it's installing all these things on your machine, so you got much more time reading articles, reading things that helps you with your job, and let Charlie do the work for you, Agent Charlie do the work for you. So, all right, so this is the first bot I wanted to tell you. Let's dive into some coding bots here. So assume you're in a cocktail party somewhere, and then you're saying, hey, people say, hey, what you're doing, and you say, I'm a developer. And everybody thinks, okay, this person just sits the whole day and codes. But that's not what we're doing, right? We're doing much more stuff. It would be great if we just code the whole day, but there's much more in it in software development. So we have to start conversations. We have to think about our deployment strategies. We have to update the issues in our issue tracker. We have to care about continuous integration server, about branch strategies, yada, yada, yada. So there's a lot of stuff that we're doing. And that is stopping us from actually coding what we want to do. So let's get rid of some of these here, or just one of these, and let's get rid of the issue tracker. Well, you might think, Sven, are you stupid? You're from Atlassian. That's what you do. You sell issue trackers, yes? But let me explain. So a typical issue tracker workflow looks like this. I mean, I've been talking to a lot of customers. This is a simple workflow that everyone can use. The issue is in to-do, then it's going into progress, in review, and then it's done. So this is a typical issue tracker workflow. But the coding workflow looks like this. You create a branch, so that's what we do. We create feature branches. So you create a branch, you code, you refactor, you actually make a pull request, and then you merge the code. So how does that work together with the issue tracker workflow? So what you do is actually issues in to-do, start, OK, I'm updating the issue. It's in progress now. So create the branch, code, yada, yada, yada. Make a pull request, update the issue, set it in review. And then you merge, and then you say, OK, I'm done here. But this is what you should do. But what you actually normally do is like this. You create a branch, you code, you merge, you're done. And then somebody asks you, what is with this task here that you should do? And say, oh, yeah, it's done. I just forgot to update the issue tracker. So it's in to-do, it's in progress, it's in reverse, it's done. Wow, 10 seconds just for an issue. That's awesome. That's so great. So you might think, OK, why do I have to do this? Why do I have to update the issue tracker? Well, it's because you want to keep the team updated. The team want to know in which state this issue is on, and where are you? Are you currently coding still, or is it done? The team wants to know where you are. So we were looking at solutions here. How can we help you to update this issue smarter? So we're looking into this here, the epic motive. You put that on your head, and then you just concentrate on your issue board and just think, yeah, let's update this issue. This issue is now in review. And automatically, without using the mouse, it's actually updating. It's cool, isn't it? It's great. Wow, awesome. But said that is actually, you still, I mean, you're just not using your trackpad or your mouse or whatever. You still have to open the issue tracker and do that. So this is stupid. That's why most issue trackers these days comes with so-called smart commits. So you can type your commit message. In your commit message, you can type in, I just start working on this issue with the issue key number, and the issue tracker can read that and updates the issue. For example, this is the Jira notation here. So it looks like this. Start review, it's going to review. And this is the GitHub notation here. This fixes number, yada, yada, yada. And then transitions the issue automatically over. Good. That's cool. But you still are switching tools. You still have to, sorry. You're not switching tools. That's cool. But the robot is just receiving commands. It's just like you have to still think, I have to update this issue because I have to update my team, what I'm working on. That's what we can do smarter. So actually, what if you have your issue and then you just create your branch, mention your issue key number in there, and then the issue tracker sees that and updates the issue. And then you're just doing a pull request, and the issue tracker is connected to it and updates the issue automatically. And then you merge the code. And then the issue tracker sees that also and do that. So when I first heard that the team in Sydney is working on these things, I was just going like, yay, I love that. That's cool. And I'm pretty sure that if you're using some other issue tracker, repository manager combination, they will do that also in the near future, because I think it's pretty cool. So let's look at some other coding bots that helps you during your coding phase. I call them little workflow helper, but they're mostly Git hooks that helps us during the coding phase. So we have an issue, and I already said that we have a branch workflow where we create the branch, we make a pull request, and then we merge. So this is our workflow that we have. Assume you have a new person that is pretty cool, just new in your team, and this person commits directly to the master branch. Well, this is not allowed at Atlassian. You're not allowed to commit directly to the master branch. You have to create a branch and then work on that, not commit directly to the master branch. But hey, And then all of a sudden, boom, the build is red. Ooh, what should we do? Well, this person is, of course, so cool. He knows this shit. So this person just updates the code, and then the build is green again. Good, great. But there was another person actually creating a branch, doing it the proper way. And then this person's coding, this developer here, and then runs the build locally and thinks, oh my God, why is it red? I didn't touch that code. Why did it fail here? And then takes 10 minutes until someone finds out, oh, it was already red when I branched it. The problem was already when I branched it. So that's really a bad surprise, but bad surprises shouldn't happen. We want to have no bad surprises. So we actually have a hook or a bot or whatever you call that prevents us from creating a branch if the build on the master branch is red. So the hook is looking at the build server and say, oh, the build is currently red. You're not allowed to create a branch. So, and this is don't branch from a red build. This is currently running in our development environment. Okay, another thing is you create your pull request and then you want to invite some reviewers. But who are the best person to invite? Who are the best person that knows really the code that I changed? Well, you can go into your repository manager and look up the commit history to see who actually changed that code, who's the original author of that code, and those persons are probably the best to review this code to make sure this is a good quality change that you just did. But said that is, that's actually a task that a bot can do, so why not having a bot doing that? And suggest actually the reviewers that are the best people to review those code that you just changed. And that's actually a little add-on that we have, free add-on for Bitbucket Server and Cloud, and it's called Auto-Suggest Reviewers. It's a small piece of code. It's also open source, so you can have a look at it. So it suggests reviewers that actually, as I said, have recently worked on that file or are the original author of that file. So always invite the right reviewers that are best to judge if this is a good change. All right. Then another small little workflow helper that we have is we want that people review code changes, and actually each line of code that gets changed must be reviewed by at least 2 persons. So we have a Git hook that prevents us from merging if not 2 people have approved that pull request. So we invite maybe 5 people to review the code, and if 2 people approve the pull request, it's fine for us to merge. We don't want to wait for all 5 to review the code. We just say 2 people is enough, then we have a minimum amount of approvers. Another problem that we had when we actually develop software for server. That means there are different versions running out there of our software, and if we find a bug in an older version, we have to fix all the versions and give that to our customers. So how are we patching old versions? So first, we have a branch for each version. So we keep those branches. And if we change something in a branch, we create, of course, a branch again, make a hotfix branch on that, and merge that then to this version branch. And then, of course, if the problem occurs in every version from that on, we have to merge it up to the least stable branch, which is our master or develop branch. But said that is, in the age of Git, merging is very, very easy, and normally we don't have any merge conflicts by merging it up, so this is a very boring job to do. And every time we have a boring job to do, well, we can get this little helper here, a bot that is actually helping us to merge all these things. So also this is a Git hook that knows the version history. And we have written a blog post about it, so you can look it up and copy it. So this is automatically merges the changes up. If it finds something that can't merge, of course, it stops there and tells you that it couldn't merge. So automatically merges, get some help with some merge jobs. All right, so coding phase, we are done. Now the next one is the test phase. some test bots. So we are engineers. What we do is we try to write beautiful code. We want to create great code, great software that looks beautiful, that is cool, that is great. And sometimes, I mean, as an engineer, you probably had that where you said, okay, this works so great together. This is so well written. This is just my masterpiece. This is my awesome class. It's so good, and you're so proud of it that you really like that. You close that file, you open it again and say, oh yeah, that was good. And then you go on vacation and come back 1 month later and look at the file again. And also other people thought this is an awesome class, but it doesn't look that awesome anymore. It went, okay, everyone added something to it. Oh my God, so not awesome anymore. Well, said that is, I've worked on so many projects in my developer career that this always happens. You cannot do anything against it. It always happens. Code gets a little bit messy over time. But why is it? I mean, to be honest, we don't want to mess things up. We don't do that on purpose. We just say, oh, this is an awesome class, let's mess this up. No, we're not doing that. Why does it happen anyway? We don't want to do that, but it happens because I think we're just so focused on solving our problems that we don't see that this might not be good. And then we move on. Problem solved, software is running, great, all tests are running great when we move on. So we have had the same problem with our Jira software, technical debt, you name it. So somebody said, okay, we need someone who really watched those files that this doesn't happen, that stuff like this doesn't happen. So we call this Drcoat. Of course, Drcoat is not a real person. It's, of course, a bot that looks after it. It's just a static code analysis. Pretty simple. And actually, an engineer wrote Drcoat when we moved from JUnit 3 to JUnit 4. Because we didn't want to migrate all JUnit 3 tests to JUnit 4 tests. We just said, okay, stop with JUnit 3. All new tests must be written in JUnit 4. So it's actually no more JUnit 3 tests. It's actually a pretty simple thing. It just counts the JUnit 3 test, compares it to a value in the database, and says, okay, you just added a JUnit 3 test, not allowed. Well, pretty simple. But people found that so useful that actually they added more and more stuff to Drcoat and say, oh, you can do this and this and this, and pretty easy to add another class to it, another check to it. So it became really popular. But what happens actually if somebody finds out that you actually added a new JUnit 3 test? We thought, okay, if this person gets an email, it's easy to delete that email. So we want to put a little bit more social pressure on those people. So you actually, if you get caught by Drcoat, you enter the Hall of Shame. Shame on you. And how does it work? Well, so we have televisions everywhere. And we call those people out on the television with a little picture of those and say, hey, this person just entered the Hall of Shame. So it looks like this on the dashboard. The higher you up in the Hall of Shame, the worse, the more you got caught by Drcoat. So fix those things. And if you fix something, if you fix a JUnit 3 test and migrate that to a JUnit 4 test, of course, there's also some reward in that. We have also a Hall of Fame, so you also can enter the Hall of Fame to it. Said that is, this is to call someone out. This is pretty a cultural thing at Atlassian. It's fine. I know at other companies maybe this can go wrong, but we're having fun with that. Okay, so what we are used to as software developers is we watch code all day. So if we see something like this, old version, new version, you probably can see, I see the eyes going forth and back and say, you caught that already. There's a magic number in there. Pretty easy to find for us because we're looking at code all day and we can find that. Okay, what about the user interface here? I don't know how high-res the projector is, not that. So said that is, we're not used at looking at user, but actually designers, they can tell you, oh, this line is 2 pixels off. And you say, what the fuck? How did you find that? So actually here, this small little icon is wrong. But designers can catch that pretty fast. So what we can do, we wanted not the interface to change. It's on purpose. So what we can do is of course, hire more designers to look at interfaces. Not the right solution. So we actually wrote a pretty simple image compare bot that just takes the image from the database and compares it pixel by pixel from the actual software and compares that. And if there's a difference, it alerts on difference, but sometimes you probably want something changed in the database. So you get an easy reporting and you can just press a button, okay, this is on purpose, done. But it calls you out if you change the line 2 pixels down, shouldn't be, tells you that this is a report from this image compare bot. Pretty easy to read. You can see this one changed, this little thingy there. I have to take a look at it. I didn't want to change it. So this is running also in the background, another little coding bot that test bot that we have. Talking about tests. As I said, Jira, I think the code base is now 15 years old, so it has been running for a long time. So we have also a lot of tests, a lot of functional tests there. And as you might know, the more functional tests you add, the longer it takes. So our actually functional test ran for hours. And we wanted to shorten it down, so we were looking, of course, the first thing that you do if you want to shorten the functional test down, you split them up, you throw more hardware at the problem, so you can run them in parallel. So we statically sliced and diced the tests, and then it looks like this. It's okay. I mean, the functional test ran through now faster, of course. We have more hardware power to the problem, but still, we're still waiting for this test to say, this longest test to say, okay, well, now we know everything is green, so we can move on. We can package and deploy it. So yeah, what we did is actually, okay, good. This is maybe not the best way to statically slice and dice the test. Of course, we can put that in half again, but then we have another long-running tests. So what we actually did is we wrote a small software called Hallelujah. Hallelujah is actually a functional test balancer, and it's also pretty simple. It takes just the functional test and looks which server is currently not running, which server is free, so I can put that test on that server. Also pretty easy. So with Hallelujah, it looks much better. So you use your resources better. At the end, we tie all the results together and we say, yay, our builds are green. We are happy the build status is green. But sometimes it happens if we have a build server that it also happens that the build get red. Well, it's okay. I mean, that's why we have a build server. It tells us, okay, we did something wrong, a test failed, we introduced a bug or something. So good. Let's look at the code. And then you think, what happens here? I can't really see why this test failed. So what are you doing? You rerun the test. You rerun the build. So okay, you press again, build, and then the build is green. And that is a frustrating moment because you just discovered a flaky test or a flaky code. Flaky tests or flaky code is not good. So what we actually wrote is a flaky test detector, something that detects flaky tests. So we don't spend engineers looking at it and rerun it and then find out, oh, it's flaky. We have actually a flaky test detector. Pretty simple also. If the test fails, we go in and just rerun this one test that failed. Just try it again. So we rerun the test and then the test is green. Boom, we have a flaky test here. So what we do is we run the rest of the build. We just run it through because flaky test doesn't tell us anything. If there's flaky code underneath, of course we have to do something. So we put this test in quarantine, and then we raise automatically an issue in Jira, so somebody has to look at it and fix it. If it's a flaky test, it's fine that the test is still in quarantine. We don't have to worry about that. Or maybe we also have to worry about that because we have to fix the test. But if it's flaky code, we should fix it immediately. And then the Confluence team were actually running it. Our test team were running it. And in the first 4 months, they actually found 817 tests that they put in quarantine and that they had to fix. So saved a lot of engineering hours, just this small little flaky test detector. All right. Let's move over to the ops side. Now we've tested everything. Everything is fine. So what we can do is now take our software and actually throw it over the wall to the operation guys. OK, great, done. We leave again. Well, OK, we know we're living in the age of DevOps, so we shouldn't do that anymore. So, but we still have some slow feedback loops. So if our service has a problem, it calls out the operation people look at it, say, maybe restart the service, I don't know, try to fix it. Then we cannot fix it. We call the developer say, OK, I changed some code here, I better change it back and then deploy it again. Small feedback loop. So we should speed things up here. Why not just, if the problem occurs, have an intelligent service that finds out, OK, this service belongs to this development team, and call just the right team, and let this team fix it. And we're using a third-party tool for it called PagerDuty. Probably you have heard of it. So PagerDuty actually knows which service belongs to which team, and which team is on duty for it, which people is on duty for that, and calls the right team. Pretty simple. But said that is, we're writing a lot of services, a lot of microservices. Maybe we have a service each day, new service each day. So we have to go into PagerDuty and configure, oh, this is the team for this service. So there's a whole lot of configuration going on, and we want to avoid that. So what we actually did is we wrote a little bot in between that actually you don't have to do that. So you just go in and get your deployment descriptor. In the deployment descriptor, you mention the team name, which team is, and PagerDuty can read that and fill out the configuration. So it's pretty simple. So PagerDuty knows which team belongs to that new service that you just introduced. Because you should own your code end to end. That's just the story here. All right. Sometimes you probably just don't release all the small features just hourly or so. You have a bigger release coming up, and you are prepared. You're sitting there. Oh, I can push the button. We can push it out. But then somebody said, have you thought about the release notes? Is that written? I said, oh, yeah, the release notes. OK, let me just actually find out what is in the release. So when you really want to find out what's in the release, you don't trust your issue tracker, you go into and look in the commit history, so you can really see. And if you have mentioned the issue key, you can really see, OK, I fixed that. Write that down, boom, make the release notes. But yeah, a lot of companies are actually not doing that. They actually use a release bot for it. So release notes bot for it. So a bot that can really read the release notes from the last release to the current release, or read the commit, and then actually get out the issue information, get the issue descriptor out, and create the release notes. Hazelcast, for example, is doing that for their releases. They create their release notes out of GitHub issues. They use GitHub, and they use actually the labels in GitHub to say this is a feature and this is a bug fix. So they label their issues and then find out this way. Zero Turnaround is also using that for creating their release notes. They actually use Jira and Bitbucket. So they use the issue types to find out if there's a new feature or so. Anyway, issue description as a release notes, pretty powerful. First, of course, you have no surprises. There's no surprise. You know this is really in the release because it's really from the commit messages. So you really know it is in the release. And then you get people write human readable issue description because they know the customer will read that. So I better write some good stuff here. And then also you think more about the customer value actually. Why when customer reads that, what does that mean for them? What did we do here with this issue? So, all right. Let's jump over to some service bots, some support problems. So we have a lot of support people that are doing support for our server products. And as you know, we cannot just look into our customers' instances directly. So if they have a problem, they call us or they email us, and then we say, OK, great, just give me your log file, and our support people can look through the log file, look for obvious stuff. But sometimes There is no obvious stuff. So what they do is they say, hey, developers, can you help us? Can you have a look at this log file? So, and we are pretty good at scanning log files. We can see, oh, yeah, well, OK, yada, yada. This null pointer exception, I know that, I know that, I know that, I know that. Oh, what's that? Oh, I have to, OK, this could be that they have done this or this or this, whatever. So we combine that with our system knowledge, and then we can go back and say, hey, they probably have this issue here. There's a big disadvantage here because we stop actually developers from work. So that means that we pause our work as developers and then help the support, help the customer, and then we come back and say, well, where are we? So stopping developers from their normal work, pretty bad. But hey, you probably know what comes now. Of course, we exchange the developer with a bot, and the bot called Hercules. And Hercules is a little piece of software. This is actually also pretty simple. So we have these Confluence pages where there's actually a machine-readable part at the header. And this is actually a regex. So we take this regex and put that on the log file and see if we can find a match. And then Hercules suggests us, oh, here we found this, this, and this. This could be the problem, and this is the solution to that problem. So you have also the knowledge base article directly connected to that problem. And then our support people say, oh, not good, not the right thing. OK, this could be it. So Hercules gets smarter and smarter because we are refining that, and we're using that internally. And we're currently running also an experiment with just letting our customers upload their log file and then let Hercules run over it and suggest what the customer should do. And the first response, one of the first responses was this: well, fuck me, the robot was right. I increased the memory and things work magically. Cool. And our support people that wrote Hercules were so proud. They say, we created a T-shirt for that. Well, fuck me, the robot was right. So they were with pride, really. So it's really cool T-shirt. Not everyone has that. So anyway, but it's not just support people that stops us from our daily job as coding. There's also some other people just saying, hello, can I just interrupt you? And you say, oh, yeah, I was just in the middle of something, but yeah, now you have already interrupted me. So also Spotify had that problem. And they built actually a pretty cool thing, a terminal, where you can enter your problem, and then they look later at it, and it looks like this. So what you're playing, yeah. So it's pretty easy. So you have this terminal. It's pretty just the front end for Jira, what they wrote there, where you can just enter your problem. It's in front of the Office door, so you don't enter the Office. You just press there, and actually, what cool is you get a printed receipt with the Jira ticket number on it, so you can say, hey, what was my issue that I just raised here? So this is pretty cool. All right, the last bot that I want to show is some report bots. So, and I told that at the beginning that I want to automate stand-ups. Well, you say, stand-ups, how can you automate stand-ups? Stand-ups is really something where humans speak together. It's just the one time of a day where we have interaction with each other, where we tell each other what we're currently doing. Yeah, but stand-ups also has some problems. Some people just speak too long. Some people are not showing up because they are in the kitchen, and you have to remind them, hey, we have stand-up like every day at 10:30, so come. And sometimes you have people working from home, so you have set up VC calls, and that takes time. And also, if you're working in different time zones, for some people it's pretty much not possible to join a stand-up. So how do we fix all these problems through bots? So the first problem that stand-ups just takes too long. This is actually the only physical bot that we have. Somebody made that. It's a little thingy, and it starts vibrating after a time. So you know when it vibrates, your time is over. So you have to hand it over, and we made it. So it stops people for talking too long and taking too much time during the stand-up, so you can keep your stand-up in a time box. Pretty cool. The other problem that people have with stand-ups is that people are somewhere else and you have to get them and say, hey, this is the stand-up, so never miss a stand-up. So what actually another developer developed is a little extension for Chrome, a Chrome tab. And Chrome tab is actually something that you configure it. It opens a tab in Chrome at a specific time and points to a specific URL. So we have pointed to Pandora, so you know if AC/DC is playing, you hear that, it's your time for your stand-up, so come to your team. It starts 1 minute before your stand-up. And if you hear Taylor Swift playing, you know it's a marketing stand-up, so you don't have to go. And we use actually the same Chrome tab also for setting up our VC calls. So we have big monitors everywhere where we can set up VC calls for the team stand-up. So also here, we have a fixed URL, every day the same, so people can go there. The people that work remote knows where to go, and it opens automatically. Nobody has to do anything, and then people are on the VC call. So stand-up bots, great for co-located teams. Great for distributed teams, but what is with teams that work in different time zones? Let's fix that problem too. So let's assume this one person works in one time zone, has a status update, tells the bot, here is my status update, yada, 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 I've done today this, this, this. And then the other person wakes up, the first person goes to bed, and then you can actually request the team update. You could use a Confluence page for that, you could use a Word document for that, an Excel sheet, whatever. But what we do is actually, we think we don't have to have a history of all what's happened. It's fine. So we use actually HipChat for it. So you just write /standup, write your update. And then if you just write /standup, and it tells you what the team has been working on, so in the last 24 hours. So it gives you all the status updates from the team in the last 24 hours. Pretty little bot, but it's used a lot at Atlassian, especially when teams work in Sydney, in Poland, and in the US. You don't have an overlapping time, basically. So they use that for that. And that's really chatbots. So if you use a chat, Slack, HipChat, whatever, there are so many bots in there that helps you. We have, for example, build bots, so that tells us if when the build fails directly, and we can have a discussion. Who broke the build. When somebody deploys software, it's automatically captured here, so the team knows in their team room that the software got deployed. If an exception happens on the production system, we use Sentry for that, and have a HipChat bot that actually puts that into HipChat, so we can also have a discussion about that. Does anyone know why that happened? Stuff like that. All right. Just 2 more minutes to go. I talked a lot about bots, talked about coding bots, test bots, ops bots, service bots, report bots. So there's not just automatic deployments, automatic builds. There's much more in software development we can do. We can automate. That helps us saving our engineering time and do more code, have more coding time. But there's, of course, one big problem. One big problem with that. And the number one problem is that also making these small little bots, that takes time. It's just like, it's an investment. Yeah. Do you get the time out of it? I don't know. I have to fulfill my sprint goals, so I have never time for that. Here's a little story. So, as I said, Jira, 15 years old software, a lot of technical debt, so we were facing that and had a really hard time. So we allocated 10% of the sprint time, allocated for fixing up the code base and make that look more prettier. But then there came this person from the Gdansk office, Philip, and he actually wrote this Drcoat and won the bot prize, the sprint time prize with it. So, and actually Drcoat not just fixes things, it actually prevents us from writing for going into technical depth. So that's even better. Also, what we do, we have every quarter, we're doing something we call Ship It Days. It's actually basically a 24-hour hackathon where we have to ship after 24 hours. And a lot of people use that for doing some fixes on the programs, on our tools, or for trying something out, but also for fixing things that are in their development time, to write some automation bots that helps them. As I said, I talked to a lot of people about bots, and the last questions I always had is, so where's the code for it? And everyone said, okay, yeah, please treat your bots well. Treat them as it's your production software. So of course, don't just put the code somewhere on your machine or on a server somewhere where it runs. Put it under source control, where people can really find that and fix it. Also, spread the knowledge about how this automation code is written by doing code reviews, like you do for production systems. Do also code reviews for your internal automation software. And also write tests, so other people can change things. They're not afraid. The test that covers that. Also write tests for those things. And the most important thing is, I think, having deployment scripts for that. Because sometimes things are running on different servers, and you have no idea on which servers this is all running. You don't have the password, the credentials to log in. It should be in your deployment script, so it's easy for people to change things and deploy it automatically. At the end, when we talk about bots, building software is a craft. And like every craftsmanship, we have tools that automation can help us. Yeah, that can help us building software. But what are we doing with this time? So creating customer value, that's really an art. And I can't see that any bot will actually, in the next 10 years, take over and create better customer value. It can help us to understand the customer better, yes, but we are the ones that create the customer value. So the time that we save on the building software, writing code, we can invest more into creating more customer value. And also, if you write bots, don't mess with bots. Treat them well. Don't do things like this. This is really not nice. Be nice to your bots. Really, they have feelings too. Not nice. Don't do that. No. Oh, that's so lame. Well, we know what happens. We know what happens if we treat our bots not well. So Skynet will come, we'll take over, we will be out of jobs. Not good. So treat your bots well, but write automation code. So thank you very much.